In Lab 2, we're focused on computer graphics using the new sprite asset file, as well as an algorithm to randomly place ships in valid locations on the player board. So here in the README file, where you should begin every lab, you see the 4 locations where we'll need to add our new code, and we'll attack it as follows. First, we'll add the sprites. Then we'll go into main.py and work on display message. This will get us comfortable using the blit command. Then we'll create some static ships, which will allow us to go into the utilities file and work on the draw ships function. And then finally, we'll end up with the play ships function, which is going to be slightly more complex because we're going to have to write an algorithm to randomly place the ships and to check whether those locations are valid. So let's start with the sprites.py file. You see I have an example provided. The message box has already been cut out. All of this is coming from the sprite sheet.png here. And so these are 30 by 30 tiles that we need to cut out, remove the magenta so they're transparent, and then we can refer to them elsewhere in our code in blit commands. So I will add a helper variables here, x and y. And we'll see how we can use these to quickly write this this code without doing a lot of pixel math. And then the width of each of these sprites is 30. They all have a margin of 1 and a height also of 30. So they're square sprites. All right, so ship top will be a new Pygame surface object. That constructor takes in a single parameter, the dimensions of that surface, the height and width. It's going to be a square. And then I'm going to use the blit command to place a cutout of the much larger sprite sheet onto this surface. And so the third argument here is the rectangle that I want to cut out of the main sprite sheet. So I want to start in the upper left corner and take a 30 by 30 square out of it. I'll put it on the end of the sprites array because at the end of this code, we go through the sprites array and remove that magenta, set the color key. Okay? So that's going to be the pattern, and we'll just do this again and again. So for ship top here, same for ship left. The only difference here would be the name. And the fact that we're now not looking at 0, 0 as my anchor point, but now let's replace these with my new variables x and y. And I can update x and y each time. So x plus equals width, I'm going to move over 1 step, but I'm going to keep y the same because the left sprite is simply to the right here. And so I'll move over by 4, then I'll increment the y by a step and go through the x's again. And if you're copying and pasting, just make sure you're careful to correctly update all of these entries. So once we get to the horizontal sprite, that is on the second row. That's the first sprite on the second row. So my x should reset to 0 and my y should step up by 1 sprite block. So here we'll reset my x counter to 0 and my y will increase by the height plus the margin. And now we can continue as before, cutting out the rest of the sprites on this row. So once we're all the way done here with the second row, that's all the sprites we'll need. At this point, if you'd like to go ahead and trim out the other sprites, the green arrow here, that will be a turn indicator, but that's not required for this lab. All right, again, the ship sunk is on the third row yet, so we'll increment the y and set x back to 0. So before we continue, it's nice to be able to make sure that we cut everything out correctly. And in order to do that, we can go back temporarily to the main.py in the area where we previously added code to draw the you and the them text, we can go ahead and add a sprite somewhere else on the screen just to visually check that we did the right math in sprites.py. So something like this will do it. Sprites screen.blit, we want to put something on the screen. The thing we want to put there is one of my sprites, like the ship sunk sprite, for example. And that's a nice one to check since that is at the tail end of all that math I was doing with the pixels. And I'll put that in the top left corner. Great. So now we see the X icon looks like the magenta has been removed correctly, and this looks good. You can try the others. Ship top, for example, and work with this until you're confident that that things look good. If you're off by a pixel or you don't see the magenta, or you still see magenta, make sure you go back and fix up the sprites.py file. Okay, so that gives us step 1. We can go back to the README and see that our next place to attack. So we've done our sprites file. Let's go ahead and do the display message because that will be a good warm-up for the draw ships function. So on line 73 of main.py will be our next spot to add code. Here we go. Display message. We're given 2 parameters, a surface and a string representation of the message. So the first thing we need to do is to create a text object, a graphic object based on the string. And we'll use the utilities function for that, of course. So as we did when drawing you and them, and also the row and column headers. So create text, and in the text we won't specify directly, we'll use the input to this function, MSG, message. And we'll use a nice large font, 42, and the foreground color, which is just black. I want to center this text now on my message box surface. So here's the box that I'm going to be drawing this message into. So I'll do the trick we talked about in the last solution where I'll use the center X and center Y methods for these boxes, or these rectangles. So this gives me the bounding rectangle for the text I just created. And I would like to set that bounding rectangle to the center of the box sprite that I'm going to paste it into, that I'm going to blit it into. Right? And that way, regardless of what the message is, it will be centered in the message box. Again, the message box is this large yellow sprite in the middle. All right, once we've got the text blitted onto the box, we need to blit the box onto the surface. And well, let's first actually do the blitting operation here to get the text onto the box. And now we'll do a similar sequence, but using the box's bounding rectangle now to center it in the screen. So I want the center of this box sprite to be in the center of my screen. Right? And that way, regardless of the dimensions of that message box sprite, it will be centered in the middle of the screen. So when we start this code, we're just going to print the message out to the console, but let's remove that since now we actually have a graphic representation on the screen itself. So the last piece we need here is screen.blit, and then we're going to put the box in its bounding rectangle. Okay. So we're going to call this code here on the event when we quit the game and say display message, the message by, and then we're going to update the display, wait for a second, and then we'll actually end the game. So let's see how this works. When I click X, by, and it's gone. Great, so that works well. One more time. Once we click X, we see the message by, and it's gone. Now, if you want to debug this, because, for example, it's not working. It can be a hassle to have to exit each time, and it's only there for a second. So we can display a message here at line 63. Hello. And this will display immediately after I've done my board drawing code. Make sure that it's above the Pygame displayed update, otherwise you won't see the result. And now when we run my game, you see the message hello. And then you can play with this and make sure that it's centered, then it's looking good. Of course, this is the buy once we're done, and then we leave. Make sure you remove this line once you're done debugging, because this is outside of the begin end code bounds. Okay, halfway there. So we've done the main.py function and the sprites.py code. Let's go ahead and go to the draw ships code. So this is in the utilities file. And you see in this function, we're given a game board and we're given some ships. We don't know who produced these ships or where they came from. My only task here is to use these two objects to put sprites in the right locations to represent these particular ships. Okay, so before I go into writing this code, let's fix up our player state so that we'll actually get some ships. The last part of this lab requires you to implement the play ships function, which will actually put ships on the board. We haven't done that yet, and it will be nice as we write the draw ships code to test it out. We're using a couple example ships. So let's just create some valid ships here, and we'll go back and change this in a minute. So we're going to create a ship, and a ship is defined by its length. Let's go ahead and create a nice long one, and its bow location, and whether or not it's vertical. So let's go ahead and create a vertical ship. We'll say true. So that'll be a vertical aircraft carrier whose bow is at location 22. And to actually store this ship into the player state object, we'll have to append it to the self.ships array. All right. Now we could statically create all 5 ships here, but then our game wouldn't be very fun to play because we'd always have the same ship locations. We'll have to come back through here later and actually make random ship positions. But since I'm here right now, why don't I go ahead and create another ship here at a different location, who's smaller and horizontal. All right, so now I have 2 ships, and I've just statically created those, so that way when I go to my utilities function, I can test it independently. Notice that every time I'm writing code here, I want to make sure that I can test it and verify that it works before I move on to the next part of the lab. And that's important because if you try to write all the code at once and just click play, and when it doesn't work, because it won't, it can be frustrating to try to figure out where you went wrong. So please work in small chunks and then test each chunk before you continue. So now, just to show you how this works, we can place a small breakpoint here at this location. We'll run our code and see what these objects look like once I get them. I expect to see a list of ship objects in a game board. Oh, and make sure when you want to hit a debug point that you actually use the bug icon when you run your code. Okay. I'll move that out of the way. So now you see where I'm paused, I have a board and I have a list of 2 ships here. The first ship and the second ship. I've expanded these out. Notice that these properties are the ones that I specified in the player state play ships function. The first ship, bow location is at 22. It's my aircraft carrier, it's 5 and it's vertical, right? That was the first ship I appended to the ships array. And the second one is my destroyer here, located at 7.7. Okay, so this will allow me to test out my drawing code without worrying about whether the play ships function works. So we can go ahead and stop the execution. And let's see how to write this code. All right. So I want to go through each one of the ships I'm given. That would require a for loop. So for ship in ships. And I'm going to need some index variables to check out where I am on the board. So it's important that you don't change the property ship.row and ship.column. That's a constant, and it indicates the bow of the ship. If you want to use a local variable to track where you are as you draw this ship, go ahead and create a new variable called row and another one called column, and that will create a nice copy of that variable. All right, so there's two different situations here. There's two different sets of sprites. There are the horizontal sprites and the vertical sprites. So as I draw this ship, I need to know whether or not my ship is vertical. Okay, when it's vertical, the bow sprite is indicated as we'll use the ship top sprite. So board dot, and now I'll use this nice utility function provided by the game board object so that I can refer to a location by its row column coordinate rather than its a pixel coordinate. Remember, the blit operation is going to require a pixel location, but that's going to be a hassle because that depends on the dimensions of the game board blocks. They're 30 pixels wide here, so the math isn't too bad. But the add sprite function abstracts that for us, so we can just use game board coordinates. If we go to that implementation here, add sprite, notice it's simply scaling the row and column by the size of the game board. Right, the X step and the Y step are both 30 here, and this also takes into account the row and column headers. Okay, and then this does the blit using the calculated pixels. So let's go back to here, and now we can say board dot add sprite, and we see that the sprite we're going to add is sprites, because it's coming from the sprites file, dot ship top, and the location that I want to add that sprite is at the row column coordinate. Of course, those are directly copied from the bow, and so this is the bow of the ship. Okay. Now I'll need to go through and add a segment for each interior portion of the ship, and finally add the stern. But before I do that, let's go ahead and handle the case for a horizontal bow. If it's horizontal, it's going to be a same location but a different sprite, namely ship.left or ship left. So the same row column coordinate here. At this point, I can test out my code to see if I have two bows. I should have the bow of the aircraft carrier and the bow of the destroyer. Great. Now I just need to start putting in the interior segments. So this will be a for loop, for I in range, and now how many interior segments are there? There are 2 less than the length of the ship because the bow and the stern count as segments. So for I in range, ship.length minus 2. And this will be at a minimum 0 for the destroyer, right, who has no interior segments. No ship in Battleship is less than 2 segments. So if the ship is vertical, the next sprite needs to be at the row below, but in the same column. So I'm going to add one to row. I'm going to keep column the same, and then I can say board.add sprite. And for the interior pieces of vertical ships, it's going to be the sprites dot ship vertical sprite at row column. Of course, now row has been updated, and so it's below the bow. Similarly, for the horizontal ship, we're going to have the same number of interior segments, but we will be incrementing the column each time because it's flat. It's going to be in this a single row, but each column is going to be different. So then I can say board.add sprite. And now we'll be using the horizontal sprite. And again at the row column location. So once more, let's run it, and we should see the interior sections of the ships that have interior sections. Great. Now this destroyer doesn't have interior sections. Perhaps we should make it a bit longer so that we can test out our code for calculating the interior sections of horizontal ships. That simply means we go back to player state, and rather than a length of 2, we'll make it a length of 3. Okay. The final step is to put the stern tile on, the stern sprite. And we'll have 2 different cases depending on whether the ship is, again, horizontal or vertical. Add sprite. For a vertical ship, we'll be using the ship bottom sprite. And we just need to put it one more row below, but on the same column. For the horizontal ship, we'll use the ship right sprite. Keep it on the same row, but one more column. So finally, and make sure you can see this, we're going to add the bottom sprite in both orientations. The only difference here is whether we put it on the subsequent row for a vertical ship or the subsequent column for a horizontal ship. And we'll play this. Great. Now we have the ability to draw ships at arbitrary locations and orientations. Note that this drawing code does not assume anything about the structure of ships. Namely, we can make different size ships in player state here. Why don't we make a mega carrier, right? What if we went here and placed a very large carrier at length 10? We'd have to put it way in the corner here, or at least so that it can go the whole length of the board. Right? And so this code is independent of the 5, 4, 3, 3, 2 kind of ship structures that the Battleship game takes. And so you can change the dynamics of the game by simply placing different sorts of ships in the player space. All right, so the final piece that we need to look at is player state. We need to randomly place all 5 ships on the board in valid locations. So this will not be using any graphic tools. This is simply an algorithm to produce ships that don't overlap and are all within the player space, within the 10 by 10 grid of Battleship. So we don't have to worry about any Pygame specific code here. We just need to go through and dynamically create these new ship objects. So at this point, let's remove the code that we had used to create static ships. And we'll go through and create as many ships as are specified in ship types. Now, ship types is just a numeric array. 2, 3, 3, 4, 5. If you want to play a different kind of battleship, we'll see that if we change these values, you'll simply get different kinds of ships. So play ship should be able to handle any list of ship types. as long as they don't, as long as they can actually occupy the board. If you can't place a size 11 ship anywhere. So to create random parameters here, we'll do the following. We need isVertical to be a random true or false. There are several ways to do this, but this is maybe the cleanest. We can create a random integer between 0 and 1. And the round is not necessary. This would come out as a floating point, and maybe the type checker might complain, but this will turn the 0 or 1 value into a true or false. Row is, of course, just a value between 0 and 9. Column, similarly. Now, the user is going to think about the rows in terms of letters, but we'll translate that into a number. We're going to be strictly dealing with numeric coordinates in Battleship. So now I can create a ship with these parameters. Ship equals ship, the ship length, and then my random values, row, column, and isVertical. Okay. So before I say this is actually good, I need to check whether or not this is valid. Wouldn't it be nice if there was some function that would return true only if the ship is in a good location? Let's just pretend that function exists. Let's call it check placement. And in order to know whether the ship's valid, there's 3 things we need to know. Is it off the right edge of the board? Is it off the bottom edge? Or did it collide with another ship? Now, in order to detect whether it's off the edge, it's sufficient to just look at the ship in isolation. If we know its bow and its length, and whether or not it's vertical or horizontal, we can figure out whether it goes off the edge. In order to know whether it collides with the other ships, we need to know something about the other ship locations. And then we'll capture that state in the board matrix, which is defined for us on line 37. Now, this is using a structure called a list comprehension, which is not something we've discussed in class, but it creates a 10 by 10 matrix full of variables that could be ships but are currently set to none. That will indicate the value of none in this matrix will indicate that no ship is currently in the space. And so what we'll do is look at all the entries in board matrix and check if they're all none. If they are, then this ship is not colliding with any other ships, and therefore it's in a valid location. Okay, so supposing that that function exists, which it doesn't, but we will make it, we can then say, great, my ship, if I got it to line 46, it must be valid. So I'll put it in the ships array, self.ships.append ship, like we did with our static placement earlier. I also need to update the board matrix so that the subsequent ships that I create will be checked for collisions against this one. So I need to go through ship length times through a list. Now I could put I here, but I'm not going to be using this value, so I'll just put an underscore to sort of indicate to someone reading the code that I'm not interested in this value. It's just a way to run through a chunk of code ship length times. So I want to set the board matrix. Now, where's the location of the bow? Of course, that's in line 42 and 43 here, right? Row, column. So that clearly is taken, and so I'll set that equal to my new ship object. But for the next element, it's going to depend whether it's a horizontal or vertical ship. So if it's a vertical ship, if is vertical, then I will increment the row. Otherwise, it's a horizontal ship, and so the next spot that's occupied by the ship is a subsequent column. Right? And so what this will do by the time I'm done with line 48, or done with this loop here, line 48 will have executed ship length times, and it will have put in, in these row column locations in this matrix, that ship will be stuck in it multiple times. Okay. Now this was it's likely that that this won't succeed, right? That the check placement will return false, and I'll have to create a new ship. So what I really need to do is wrap this whole structure in a loop while true, continue to try to create this ship until we're successful. Right? And we'll make sure we're still within the bounds of our code. So do this until successful while true. Now, if I succeeded at this point, this means that I was successful and I should break out of this while true loop. Okay? So that's what I need to do in order to place all these ships, but I've still got this wishful thinking going on that this check placement code works. So typically what you do at this point is create another function elsewhere in the player state object or player state class. But since we need to stay within the begin end code markers here, we can actually create the function within this function. So it's going to be nested inside this function. This is not typical, but will allow us to create a function and use it locally. So what I can do here is check placement, and that's going to be getting the board matrix as well as the ship. Okay. So here I'm going to go through and check whether the ship is off the board, meaning that the row or column coordinate of a part of that ship is larger than 9, or is a row column coordinate already taken, which meaning that the board matrix row column location is not 9. So I'll create a local variable here. Remember, we don't want to change the ship bow location, so I'm going to be updating row and column as I go through this loop. As I check all the locations of the ship, I need to make a copy of these variables. So I'll use a similar structure for the for loop as I did below. I don't actually need to know what the loop iteration counter is, but I just need to do something ship length times. All right. The first thing I want to make sure is it's not off the edge of the board. So if either the row or the column is off the board greater than 9, this is not going to work. Return false. Now, how do I check for collisions? Well, if board matrix at that location, row column, currently has a ship in it, that's also bad. Is not none, meaning there's a ship in there. Return false. All right, those are my 3 checks. The first 2 are combined in a single if statement. Now I need to update row and column so that I check the next spot in the ship. So if the ship is vertical, the row needs to be updated and the column stays the same. Otherwise, the column is updated. Now, if I get through this whole for loop without ever returning false, well, then it's a valid location and I can return true. All right, so at this point, we should be able to place in a ship of length 2. We'll make sure it's valid, then we'll make a 3 length ship, then another 3 length, then a 4, and then finally a 5. And here is a very dense cluster of valid ships. We can close out Battleship and run it once more. And now we see a different ship layout. If you run this code and notice that ships are overlapping, that means your board matrix is incorrect. If you run this and you don't see the stern of some ships, that means you're not checking whether the row and column extend past 9. As you write player state, if you haven't already done the graphics, or you don't trust that the graphics are perhaps correct, you can go to the human.py file, and then this is where our place ships, the function we just wrote, actually gets called. We can set debug equal to true. When you do that, you activate a section of code below where we wrote the place ships function. So if debug, normally that's false, but if we set it to true, it will give us a text representation of our ship layout using the board matrix. So it's going to go through every element in this 10 by 10 matrix, and if that particular location is not none, it's going to print the length of the ship in that spot. If the location is none, it will print an underscore. And so let's see what that looks like. So here, you see right below the Pygame welcome message is a text view of the board. The first row is empty, and that is indeed the case. The next row has our 2-element destroyer. It's a horizontal ship, and that also looks correct. We have 2 more blank rows, and then we see our carrier and the other 3 ships. Now the fonts are rectangular, so the aspect ratio of this board is skewed, but you should be able to use this debug view to make sure you're populating the board matrix structure correctly. If these two do not match, make sure you go back through the code and fix it. Once you've got this working, then you're done with the lab. The next step is to start playing Battleship.